This is Mrs. Butcher, and this video is on ellipses. This is section 9.4 in your Algebra 2 book. Okay, so the technical definition of an ellipse is the set of all points in a plane such that the sum of the distances to two fixed points is a given constant. And I demonstrated this in class with some string. So here we have two pictures of standard ellipses, horizontal and vertical. We've got all the major parts labeled on here. We've got a major axis, which is the long one, a minor axis, which is the short one, and then we have foci, vertices, and co-vertices. Let me highlight those. There's foci here. I think I just covered up the F's. There's co-vertices here. There's a vertex here and a vertex here. And then we have the same thing with vertices being on the long axis on your vertical ones. Your co-vertices are always on the short axis. We have our foci. And then we have A, B, and C, which I'll talk about in just a minute. Okay, so when you have your ellipse, the equations for the ellipses, the horizontal equation is always going to be x minus h all squared over a squared plus y minus k all squared over b squared equals 1. It always equals 1. And then for a vertical, it's x minus h all squared over b squared plus y minus k all squared over a squared equals 1. And that's because A is always your longer axis. So if it's a horizontal ellipse, A is the distance from your center to your vertex. And if it's in the x direction, it's under the x. However, in your vertical, A is still your long radius, your distance from the center to the vertex, but since it's in the y direction, it's under the y part. Then B is going to be the distance from your center to your co-vertex, and that's going to be vertical here or horizontal here. And then we also have C, and that would be your distance from the center to a focus. It's the same on either one of these. Your foci are always located on the major axis, and the relationship between A, B, and C is always a squared minus b squared equals c squared. So these two are on your formula chart. This, however, you're going to have to know that a squared minus b squared equals c squared. And that's all the parts. So in this example, we want to graph x squared over 16 plus y squared over 36 equals 1. So the first thing we're going to do is decide if it's horizontal or vertical. And we're looking at bigger number here. So that tells me, because the bigger number is under the y, it's going to be vertical. It tells me that a is the square root of 36, which is 6. And then b is going to be the square root of 16, which is 4. We could figure out c, because we know c squared is a squared minus b squared. So 36 minus 16 is 20. That makes c the square root of 20, which can be simplified to 2 root 5. And so now that we've got a and b and c, we can graph this. All we need to do is locate the center. Center is always at hk. We don't have an h here, we don't have a k here, so our center is at 0, 0. Then, in the y direction, we're going to go 6 units, up and 6 down, and put our vertices. I'm going to put v's by them. So if we had to write them down, these points are at 0, 6, and 0, negative 6. So I'm going to put plus or minus to save space. Okay, now in the x direction, we're going to go 4 units, left and right. And those are our co-vertices. I'll put CVs on them. So those are at positive and negative 4 and 0. And then we must plot our foci, and those always go in the major axis, so in this case the y-axis. So they're going to be at 0, positive and negative 2 root 5. And when you're plotting this, you can say, all right, well, 2 root 5, that's about 4.5. So 4.5, put an F on that. 4.5, put an F on that. You've got your foci plotted. All you have left to do is connect the dots. It's kind of difficult, so if your ellipse is ugly, that's okay, as long as these 6 pink points that I have on here are in the right place and written down, then you are good to go. For this next one, we're going to graph x squared over 49 plus y squared over 4 equals 1. So this time, because the 49 is bigger than 4, and it is underneath the x part, we know this is going to be horizontal. And a is going to be the square root of 49, which is 7. B is going to be the square root of 4, which is 2. And then a squared minus b squared gives us c squared, which is 45. So c is the square root of 45. 45 is 9 times 5, so that's 3 root 5. All right, we have everything we need. Our center at HK, no H, no K, that would be at 0, 0. In the x direction, we're going to go 7 units to the right and to the left. So 7 this way with a vertex, 7 this way with a vertex, and we'll write them down. Those are at 7 and negative 7, 0. So we'll put plus or minus 7, 0. Our co-vertices are going to be 2 up and 2 down. We'll write those down. Those are at 0 and positive and negative 2. And our foci, which go on the major axis, so in this case the x-axis, are going to be positive and negative 3 root 5, 0. 3 root 5 is about 6.7. So your foci in this case are going to be right next to your vertices. So we've got everything plotted. All we need to do is connect the dots to make our ellipse, and we're finished. This time we're going to graph one that is not centered at the origin. So in this case we have an h value, and that's 2. And we have a k value, and that's negative 1. So our center is at 2, negative 1. Right there. And every point that we plot on here is now coming off of the center, not the origin. So we need to decide, is this horizontal or vertical? 36 is bigger, and that's under the y part, so this is vertical. A is the square root of 36, which is 6. B is the square root of 16, which is 4. C squared, we did the same 36 and 16 in the first problem. 36 minus 16 is 20. So C is 2 root 5. Alright, so from our center, in the y direction, we're going to go up and down 6 units. So we're going to count 1, 2, 3, 4, 5, 6, and put a vertex. And down 1, 2, 3, 4, 5, 6, and put a vertex. So then we need to actually write the ordered pairs of those vertices. This one up at the top is at 2, 5. This one at the bottom is at 2, negative 7. Alright, now in the x direction, we're going to go 4 units left and 4 units right from the center. So 4 units and 4 units. Those are your co-vertices. And we'll write them down. The one on the left is at -2, -1. And the one on the right is at 6, -1. And then our foci are going to be 2√5 units away from the center. Remember, 2√5 is about 4.5, but I don't want you to say about 4.5. The only reason you need to know that is so that you can count on your graph. 1, 2, 3, 4.5. But when you write these down, you're going to have to say they're both at 2, comma, and then the y's both started at -1, so I'm going to say -1, and then we went up and we went down, so I'm going to say plus or minus 2√5, like that. So everything's plotted, everything's written down. Let's connect the dots. And we have our ellipse. Okay, in this example, we're going to write the equation of an ellipse with the center at 0, 0, a vertex at 0, 6, and a co-vertex at -3, 0. So like I've told you guys before, it always helps to just sketch a quick little picture. Center's at 0, 0, vertex is at 0, 6, and co-vertex is at -3. So just by looking at that, this gives me the fact that it is vertical, because your vertex is on the y-axis. This gives me the A value of 6. It gives me a B value of 3 units. And H and K are 0, 0, so we have all the letters we need to fill in the equation, which is for a vertical is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. And we're just going to fill in. H is 0, so that's just x squared. B is 3, so over 9. And then y minus k, well, k is 0, so y squared over 6 squared, which is 36, equals 1. So when you have these word problems, you just need to draw a little picture for yourself of what the information that they give you, because then you can determine the letters, the things that you need to fill in the equation. And one more example, we're going to write the equation for the ellipse with the center at 0, 0, co-vertex at 0 square root 7, and focus at -3, 0. So if we sketch this out, our center's at 0, 0. The co-vertex is at 0 square root of 7. So that's a co-vertex this time, and it's the square root of 7 here. And the focus is at -3. So what this gives us is that it's going to be horizontal. It gives us a B value, because B goes to the co-vertices, of the square root of 7. It gives us a C value of 3. And we just need to solve for A using A squared minus B squared equals C squared. So we're going to say A squared minus the square root of 7 squared equals 3 squared. A squared minus 7 equals 9. A squared is 16. That means A is 4. Alright, so now that I know A, B, and C, and H and K, because that's H and that's K, I can write my equation. This time it's horizontal, so it's going to be x minus h, so x squared over A squared, which is 16, plus y minus k, which is 0, so y squared, over B squared. If I square the square root of 7, I get 7, and it equals 1. It always equals 1. And that's that. We're done with this video. You guys have a good night.